Hi, this is Cliff. This is Coffee Compiler Club, where it's an open conversation about anything to do with compilers and language implementations and runtimes and typing systems, including circular types we're just about to dive into. And open mic, ask what you want. Conversation goes where it goes. I don't have any set agenda. I reserve the right to moderate, never had to do it. You're being videoed. It'll show up on Twitter, generally within a day to a week. That being said, yeah, carry on. So, York, you were saying.
Yes, I added the link to the Google Doc as well. I think that a sort of brief summary is basically when you have a ownership model where specifically you allow moving of objects when references to it still exist. You can create cycles. So the simplest example, you have a linked list node. You create you have an owned one specifically. You create a reference, let's say n, and then you do something like n.next equals the owned value. And you end up with a case where the owned value on the stack can no longer be used because it has been moved. But because it has been moved in itself, it won't be dropped either. And so you end up with a leak. The paper that I based my implementation on describes this, and basically their argument is like, this is stupid. You can't, like, you won't really run into this, so you don't do anything with it. Don't do it. Which I agree with. I think it's a perfectly valid point. But there was a discussion on sort of how you might be able to avoid that, the trade-offs and such. And I spent some more time thinking about it, and I think really the only way you can guard against it is if you disallow moving of something when there are references to it. Because otherwise you'll always have some sort of way that you can do this.
So the Azul collector is obviously both a moving collector and a concurrent one, and so it moves things with references to stuff. You just have to maintain a tricky invariant about who's got the correct value.
Right. Yeah, and so the thing here is like at sort of the runtime side, this is annoying. You leak an object, but I think in the worst case, well, you can only leak that single object, and it's not something you can easily do by mistake. So it's not like you're suddenly gonna leak a 2 GB byte array or something. You only run into it when you have these recursive types like linked lists, graphs, those sort of things, and I think most people wouldn't really run into this in practice. And the trade-off, at least in the type system, is that you have to basically do something like Rust, where you have a very strict type system, which comes with its own trade-offs. I think I wrote down somewhere on paper like 5-6 different approaches that you could take, but none of them are 100% accurate.
Wait,
they're all case like.
Back up. I was busy doing maintenance and I missed the core thesis. When do you get this cycle here?
So the core cycle you can create is, let's say you have a node class and it has a field called next, which can store a owned node. So not a reference, an owned value. What you can do is something like, you create an instance of that node and then you assign it to its own next field. So you do something like n.next equals n. And that works because the field is owned, the input value is owned. The result is
owned here means single threaded, no other pointers to it.
Yes.
Okay.
Yeah.
Fine.
And
this is in context of a garbage collected or a ref counting system.
Or it applies to both ref counting and single ownership.
Okay.
Like for a trace and collected, this is not an issue. But the issue here is if you have single ownership, it's sort of technically it is correct. Like you're not going to get undefined behavior errors, whatever. You're just going to end up leaking an object because it gets moved and thus it doesn't get dropped. But because you move it, you also can't use it anymore.
Is this different than any other circular dependency problem?
No, it's kind of similar.
The linked list to the tail.
It's basically that problem. The thing is, if you have traditional reference counting, you can still use the value afterwards. You just have a cycle that you somehow have to break manually. And so in theory, you can have a leak, but if you somehow decouple that cycle, in practice, you won't. But if the value has a single owner, then after you create the cycle, you cannot deconstruct the cycle because there's no way to use that object anymore.
Right. Right. So you do have a leak there. Yeah. That makes sense.
And it's one of those cases where it's like, in theory, this is a problem. For me, it kind of falls in the region like, in theory, if a certain radioactive particle hits your CPU, then your software might do something weird. And, we don't guard against that either. Because for most people, it's just not needed. And the one benefit here is if you do something like node.next equals node, it's quite obvious that it's wrong. Because you'll see that. And you're like, hey, wait a minute, why can't I use node anymore? Like, oh, wait, it's because I moved it in itself. Let's not do that. And that's basically what the paper that I based it on also stated. They're like, yeah, it's possible, but in practice, it's probably just not going to happen.
Well, or maybe it happens and you don't care.
That's the thing. Like, at the end of the day, I think any flaw will have somebody that triggers it at some point. But here the trade-off is basically you can prevent it, but it requires a significantly more restrictive type system, as far as I know, at least. Or you can just let it be and say, it's the trade-off of having a simpler type system.
You have an ownership type that demands that there's somehow an external owner to a cycle or two cycles or something.
Well, so the Rust way is basically you can't move when there are references to it, and that's more because those references might be invalidated if the type is copied, for example. But that does prevent this from happening, because if you only have the own value and you can't move it through a reference, like that, you can't introduce cycles. And I thought for a moment, like, hey, maybe what you could do is you can split your types into types that go on the stack and types that go on the heap, and then disallow circular types. So if you have a node class, it can't have a field of type node. It must have a field of type boxed node or a pointer to node, some indirection.
Right.
And I was quite excited, like, oh, I think that might do it, and it has some added benefits that inline types basically become part of your type system. Yeah. And then I realized, wait, but then you can just box the node and assign the field through that, and you're back to square one, basically. I was like, damn it, there goes my idea.
Right. I mean, I certainly use circular types all the time. Show up in compilers left and right.
Yeah, but so circular types through using references is fine. So you can have a node that, say, a doubly linked list. A stupid example, but it's the simplest one. The previous field will be a reference to a node, and in theory, it could be the node itself. And that's totally fine, because the way the fields are cleaned up, at least in the paper and what I've yet to implement, is that they're dropped in basically reverse lexical order, though the order doesn't really matter as long as you clean up the references first. So it drops the references, then drops the own value all as well. And so through references, it's no problem, because you can't leak. The worst case, you have to implement a destructor to drop fields in a certain order. But if you don't, you get a runtime error, so not a leak. It's this. Well, so in this case, the paper in my implementation, if you have a own value that you drop while there still are references to it, it will produce a panic. So it will just abort the whole program and say, this is wrong.
Yorick, can I insert a tiny question?
Yeah, go ahead.
Do you know what year this paper was from? I can't quite find it.
2006.
2006, nice.
Roughly,
thank you very much.
They link to some. I don't like how papers don't have published dates in them.
I know, right?
I usually go by either the most recent reference in the paper or some link. In this case, they link to a Google Code project, and the commits are from 2006.
The issue with not having your date in the published date in the paper is because you submit it to a dozen conferences trying to get it in. somebody accepts after 3 months or 6 months, and then it gets published when that conference comes out, which gets delayed and postponed for COVID and shit like that.
Yeah,
So
the date I want in the paper is last text modified.
Yeah.
Right.
Yeah, that's not a bad answer.
I want to know if you change a single character in this paper, update this number. Last
that's
text
not a bad
modified date, not the date of the conference, not the date of the journal.
Well, the historical context is so important, and it's often implicit. You have to go look at the most recent reference. It's just implicit. So
Right.
I wish it was stated somewhere.
All papers should be shipped as Git repositories.
Yeah, absolutely.
That didn't work
Absolutely
when I
agree.
started this
Okay.
game.
So here's the new plan. The first reference on every paper is I'm referencing the NIST time servers, which say that the time is.
You could reference yourself. You could give a self-reference. You could say 2021, C. Frederick, blah, blah, blah. And then everybody would know how to cite your stuff too, because they just copy paste the reference that you made.
Oh, well, that's interesting.
Oh, but that needs to know what journal it got accepted into.
Now it's a circular thing.
You still have to get
Yeah.
the publisher.
Not to mention the recent papers has become much more complicated to read. I can just recognize the paper is it from the 70s or 80s because it's such an easy to understand. It's so simple. It's explained it so clearly. But the recent papers has become. Oh boy.
I've literally gotten the feedback on papers. Can you replace all of these X's and Y's and Z's with Greek letters so it looks more professional?
Yeah, and you have to use a particular font as well. Otherwise, it's not a real paper. So as long as you use the right font, it can be like the stupidest topic and the stupidest.
Why the font?
ever.
Why the font is so instrumental to the paper?
LaTeX font.
Well, yeah, if you
Yeah.
pre-LaTeX, you had typewriter font only.
If you write it in computer modern, it's true. It's just how the world works.
Yeah, like regarding the symbols, I was so annoyed with all the. So I didn't do academic degree or anything. So all these symbols, they're like voodoo to me, basically. So I ended up at some point asking for Christmas a few years back this book called Mathematical Notation from Edward R. Scheinerman, if I pronounce it properly. It's like super thin, but it basically has the common symbols, the explanations. But I think somewhere at some point it starts, it's like, hey, this is the symbol. It can mean 5 different things depending on the author because it's ill-defined, basically. Like, great, thanks.
No, it's important to know that it means like trash according to context, and you have to just go sort it out. Because otherwise you think, oh, it only means this, and then you're really confused. And later you discover, no, this guy was using it this way, and that guy was using it that way, and this other guy da. Sometimes it meant this plus or minus standard deviation, and sometimes it meant the mean, not the mode, and sometimes, what the fuck.
I've definitely had papers that I was reading as if the symbols were intersection and union, and only a third of the way through the paper do I realize it's and and or.
Yeah, right. Yeah. I've been there, done that.
Which are surprisingly hard to tell the difference between set intersection and set union and binary logical and binary logical or, because they're almost the same.
Yeah, right. Yeah. Jargon. I went down this path of trying to talk about what I was doing with type theory with a bunch more intensely academic group. And we spent the first month, 4 meetings at 1 to 2 hours a pop, sorting out jargon. Really, I said this, and they're like, "Oh, cool, but this doesn't make any sense." And blah blah blah. Conflict. No, you're backwards here. No, you're backwards. I'm back. Okay, so we sorted out. There was a flip up and down and left and right. There were like 3 more flips and miscommunications left and right. It really took a month before we had the jargon solid. It's incredibly bad.
Apparently, if you wait long enough, the polarity of lattices flip periodically.
Yeah. I got taught lattices in one way, and apparently somewhere in the 80s or 90s, they flipped to the other way. So I am technically currently backwards against the universe, but I've been doing the same way for 40 years. So it's like hard for me to just flip myself on my head. Everyone else has been doing it 20 years backwards. So I don't know.
So I hypothetically took a compilers class and technically work with lattices every day. What's a lattice?
Oh, you go get the Wikipedia article if you want the detailed thing. You want the simple answer?
I want, yeah.
a set of nodes such that any two nodes have a common meet point when they go up and a common join point when they go down.
Yeah.
For any
it's like
pair
two
of nodes
trees
in the
join?
lattice.
It doesn't have to be trees. And the Wikipedia article is really good. They show some like the smallest possible non-lattice things. They talk about Hesse diagrams, what we're talking about. You draw a Hesse diagram. It's like two intersected upside down trees. They don't have to be symmetric, but they often are. They don't have to be finite, they can be infinite. There's a bunch of math things that go around with them that if you have the right properties where you don't have to be, you can be infinite and that's still have all the right properties. You get a lot of cool shit out of it. But for everyday compiler work, the easiest lattice that you'll ever see is constant propagation, which has a top and a bottom and a constants in the middle, and it starts at the top and spreads out to every constant and joins back to bottom. And you run the classical constant propagation algorithm where you just walk over the program and you have an abstract interpretation for like the add says, I have two inputs, so they're both constant, I can compute a new constant out. But if one of them's bottom, I don't know what the answer is going to be, so it's bottom out. And one of them's top, I don't know what the answer is going to be, so it's top out. So you have a set of transfer functions and you have a lattice. If your transfer functions are monotonic, that is to say, whatever answer you got from two inputs to the add and you got an output, if one of your inputs changes monotonically in the lattice, the output changes monotonically. I mean, the same, or it could change, but monotonically. So if your transfer functions for add, subtract, multiply, divide, and or, stores and loads and ifs and everything's monotonic, you have a what's called a monotonic or monotone analysis framework. Now you can prove that there is a single best answer. You can get it in linear time. In fact, very, very quick linear time. And you'll have it, whatever, you get it every time, right? So that's the classical constant propagation algorithm falls into that category. But then as soon as you have a monotone analysis framework concept, you can pile in lots of things into that concept. And that's all ties into the lattice in the end. And you can get all kinds of things in monotone analysis framework, which is what my thesis was, is why I know way too much about this shit.
So I did a constant propagation pass once, and it did a tree walking thing and tried to join a bunch of nodes.
Yeah.
How do those two things relate? I feel like we've described completely different.
Okay. Yeah. So the what's the right way to go here? The tree walk gives you a particular visitation order, but the theory is sort of independent. So imagine, if you will, that, so I'm not sure if I want to go down this path here. I'll try this path and you can tell me if I'm talking nonsense or not. So ultimately, we're going to define a set of equations where the equations represent your program's evaluation, abstract interpretation, evaluation, semantics, where you have one variable for every interesting program point, and you get an equation for every one of those. So you have inequations and unknowns, and you solve it. The equations themselves are taking the values from the current program points, applying the transfer functions, the abstract interpretation of add on a lattice, and producing lattice results in. So lattice results in, lattice results out. You have a big pile of equations, you solve it. Okay, that's the general. Yeah.
Take it down like 5 grade levels. Pretend I'm a dumbass. Like I feel like there were a lot of new words introduced there. And
okay.
if this is
so,
not,
well, if you know how to solve inequations and unknowns.
Sorry.
Do you know how to solve in general inequations and unknowns, like high school algebra?
Yeah, like a matrix kind of thing.
Yes, matrix solver. High school algebra. That's all I'm talking here. So just leave it at that very general notion. We don't have to go any more deeper there.
But we at some point we had a program, and then now there's a matrix.
Yeah, right. I took your program and represented it as a matrix by saying for every point in the program, so I have x equals 2 plus 3 as a program, right? So I have an equation for x. It's defined to being the abstract interpretation for plus a constant 2 and a constant 3. So I actually have 3 program points that are probably of interest here. I have a constant 2, a constant 3, and an x. So I make 3 equations, 3 unknowns. Okay, well, 2's abstract interpretation is 2 is equations trivial. So for 3, x has an equation that says I take the value I got for the equation for 2 and the value I got for the equation for 3, and I push it through the abstract interpretation for add, and I get an abstract value for x. So that can be extended to the whole program. Most of those equations don't talk about other program points except their immediate neighbors. So x equals y plus z. X talks about y and z, but it doesn't talk about q, r, s, t, a, b, c, and anything else. So the pile of equations you get out have mostly zeros where you don't talk about things. So you have a form of a matrix which is mostly busy along the diagonal and mostly zeros off the diagonal. And this is a well understood in the numerical theory world of how to solve these things efficiently. You go to a graph format because most of the matrix is zero. You just want your neighbors that are non-zero. That's a graph. So that's the translation from equations to graph. You can do the same translation to trees. So ultimately, though, you want to carry in the back of your head, I'm just solving inequations and in unknowns, but then there's an algorithm that's a lot more intuitive. In the case of trees, you do what you did. You walk the trees down to the leaf. You hit some leaf value where you said, I got something directly from this leaf without any further ado. And then I worked back up and I took my two children and I have an abstract interpretation for an add of y and z, and that's the value for x. And up the tree you go. And the only thing that gets weird there is what do you do about cycles? And then you have to do something funny where your cycle says, I'm a loop node and I have a bunch of values that are falling in and also coming around the back edge. And what do I do here? And I have to do something funny. In the land of graphs, we put phi functions in, it's SSA form. In the land of equations, all the equations talk about all the equations, you already got cycles left and right. So the equation shrinks down to the SSA form very directly because the phi functions just show up in the graph IR, they're already in the equation format. But you get the same thing in the trees. And ultimately you're solving this in equations and in unknowns. And the reason to talk about it in the equation format is because then you can get some very old and well understood mathematical properties out that say shit like there is an answer. And you can get it by solving it this way, which it turns out in the case of trees or graphs turns into the classical incremental fast linear time algorithm. But all these things fall back to, hey, in the land of pure mathematics and inequations and unknowns, I could just solve them however I want to, including substitute one for the other and subtract adjacent equations and start removing terms out by doing it that way. That same exact math model, but represented in a graph form or a tree form or an equation form. And fine. Does that get closer?
I think so.
Okay.
It makes sense, but it's not usually the way I think about it. I usually think about it more as I'm some point at a program. Some set of values can reach me.
Yeah.
So what is the things that I can be? Well, it's the union of all the things that can reach me.
Right. And you've gone to a graph format already and you're flowing values in. Yeah.
From me,
yeah,
that value can go to some set of places.
Right.
So what properties better I hold? All of the properties of the things where the value is going to go after me.
Yeah.
Yeah, the key
And you could do that with union and intersection and just be like, I have this thing that's all possible values that can exist.
Yeah.
But that's an infinite thing, which is kind of hard to work with. So I can approximate it with a lattice and be like, oh, 2 came to me and 3 came to me. I need to figure out where 2 and 3 meet. I'm going to say not that they meet at the set containing 2 and 3. I'm going to say they meet at int 8.
Yeah.
It is something between 0 and 255. So I can just broaden out that way and get faster runtimes by approximating all my unions and intersections in safe, overdone ways.
The notion there is that you must approximate or you run the program. Yeah, but if you want to get a quick answer out, you have to approximate. And the quality of the approximation tells you something about the quality of the answer you get, but the kind of approximation you do, if you stick to those things that fit in a lattice, you get the properties out that the algorithm that you're running terminates fast, gives you a single best answer and terminates fast. So that's the reason we care about lattices. They represent the kind of approximations I can do that I can also run efficiently and get a guaranteed best answer to the limit of the approximation.
even give you basic guarantee of termination in the first place. Consider that you could have an unlucky implementation which oscillates between different values. Say you are analyzing some kind of control flow graph when you have a loop, and you jump from the basic blocks over and over and over again. What you would like to get is a guarantee that there is going to be a point, an iteration, when the values of your analysis no longer change. We call this a fixed point.
Yep.
And then you know that your algorithm is actually going to finish. And that monotonicity, what Cliff mentioned, that's one of the conditions required for the transfer function on the lattice to hold.
I have certainly implemented bugs in these kinds of analyses where I failed to be monotonic and had that oscillation where it just never terminated.
So in monotonic, do you mean like it always goes one step forward?
Order preserving. So it means that if the inputs to a function are increasing, for example, then the function outputs are also increasing. So you can think of this of increasing precision of approximation, right? So if your analysis gives you more and more precise results and is fed more and more precise inputs, then the precision is also going to increase. You won't suddenly drop precision when the inputs are increasing in precision, which would be one cause of the possible oscillation that you could see, and then non-termination.
Let me add that it is okay to not move. If my inputs change in one direction, the output doesn't have to move. It can stay the same.
Yeah, so let's say I'm looking for the place where I've joined a bunch of integers and like 1 comes in and I'm like, okay, 1.
Yeah.
And then 2 comes in and I'm like, oh, it's 1 or a 2. I'm going to say this thing is an int 8.
Yeah.
And then 3 comes in and 4 comes in and 5 comes in and that's fine. And then you give me 1,000 and I go, oh, drat, 1,000's not going to fit in the int 8. I need to go to an int 16.
Yeah. And when does that terminate?
No matter how many times you start adding 1s and 2s again, I'm always going to be at int 16. I can never go back down. I have monotonically jumped up. And when you hand me 20,000, now I'm going to int 32 and I can never come back down because no integer that you ever add is going to say, oh, I now have a tighter bound than I used to have. So it's monotonic. It only ever gets bigger.
When I give you an example here, I was first implementing ranges in HotSpot, so C2 compiler from 20 years ago. And I'm doing ranges, so the obvious reasons that people do small integer ranges and just switch statements and shit like that. So I had a for loop for I equals 0 to n, where n is an unknown integer value. Well, at the start of the loop, I is 0, and then I is I plus 1 comes around as 1. Now I is a mix of 0 or 1, and I go to a range of 0 to 1. Great. So down the body of the loop, I add 1 in the compiler, to the range 0 to 1. Well, that makes the range go from 0 to 2. So I come back around to I is now 0 to 2, and then I add 1 comes 0 to 3, and 0 to 4, and 0 to 5. And how long is the compiler's analysis going to run? Well, it's going to count up to 4 billion before it wraps. So that was essentially an infinite loop. So I had to do something about widening of integer ranges such that it stopped widening after a while. Otherwise, my loop was my analysis was not bounded by a reasonable amount.
When do you stop widening?
3. Not the count, not the size, not the number 3, but the count of 3 widenings. So there's integer ranges have a count of widening attempts. And widening specifically only happens at phi functions. So phi function takes in 2 sets of things that are integer ranges or an int and a range or whatever. All integers became ranges. When the phi function looked, if one of the ranges dominated the other completely, that was your answer. But if they didn't overlap exactly, I had to widen. And the output was a new widened range with the widened count bumped by 1. This repeated until the widened count hit 3, and I gave it up and said, fuck it, you're an integer. And I widened you to all ints, and I was done. So the lattice depth was 3, right? That was the bound of the depth of the lattice, which is how many times I could widen. So in the standard constant propagation, the depth is 3. It's top, integers, bottom. Manuget lattice is top.
So bottom is no integers. Top is integer, or no?
Top is okay. So in my terminology, so sorry about the 20-year-old flip-flop. Top would represent, I don't know what kind of integer value you are. You could be any constant. I'm going to act as if you were all possible constants all at once in the best possible way for the compiler. And then bottom is, I don't know what value you are, but I have to compute you the hard way. I must do the math, and you're no constant anymore. I can't replace 2 + 3 with 5. I have to say, do the add of y and z because they're no longer constants. So the add's not a constant. I have to do work. So top is the best case, if you will, for the compiler. It's, yay, you're anything I want you to be. And bottom is, oh, I have to do it the hard way. I have to work at it. So in the lattice of ranges, there's a top of the best case of, yay, you're anything, to you're a range of the first time I saw you, probably a range of 1 value. You're a range where probably you've been widened. You're widened a second time, you're widened a third, and then you're just a bottom now. You're in integers. So this is still all just integers.
One could call this, I may have different orientation, but perhaps not. So one I would call unreachable, the other I would call may vary, and the stuff in the middle I would call constant. So you probably flip this compared to me.
Don't use unreachable, because very specifically unreachable has a meaning, a jargon meaning already that says this code cannot be reached. I have an if statement. If x is greater than 5, well, x is 1 or 2 or whatever. It's not, that code is not reachable. And a well-known constant propagation extension, the conditional constant propagation algorithm, takes advantage of that to not pick up unknown values on dead code paths. So unreachable is a poor term to use for top or bottom. I like top to be thought of as uninitialized. It might be a little closer to the.
Yeah, uninitialized is good. Yeah.
Okay. Here's a program for you. I'll throw it in the C program. I'll throw it in the Google Docs so I can find it. That represents like the evil shit that can happen with uninitialized variables.
Cliff, in HotSpot, is the implementation of this lattice in CI type flow, or is it somewhere else?
CI type flow was a precursor to the C2's internal IR. The CI type flow was nothing to do. It was like somebody was trying to do something with the bytecodes because the validator didn't put strong typing information on the bytecodes that I needed already. And I was doing type inference on bytecodes before, or as part of trying to get into the SSA form. So it is not CI type flow, although I think they're related. God, I don't remember now. The CI type flow came later. That's what I'm trying to remember. All right, I'm going to claim I don't know here without looking at CI type flow, because it turned into a wrapper around the core internal types, which would be the lattice, the core type system, type HTTP, type CPP, that's the lattice.
Okay.
Right. Okay. So my little program here, what is and predicate's just, you know, whatever I want to do with some predicate came in off of main arguments. It terminates after a while. So predicate's a function that runs a few times and then quits. So what can the compiler say about the value that returns for x here? So x is uninitialized, it's a C program. He tests an uninitialized value. What is that value? Well, different compilers will do different things. In the land of you know, somebody's direct interpretation, like I do an obvious code generation here where I do nothing smart at all. I just just implement code like an interpreter would. Okay, so I would read the uninitialized variable. Let's say it's 0. I run statement 1. I set x to 0. It's now a known 0. When I loop, x will be 0. I only ever run statement 1, and we'll return to 0. Suppose I come back through and x is not a 0. It's a 17, or it's a pointer to your secret key. I don't care what. Then it's not a 0. So I run statement 2. I set it to 1, and I loop. It's now a 1, so it's never x is 0 again. I only ever run statement 2, and I return a 1. Okay, why do I turn a 1 or a 0? Well, I return to 1 or 0 according to uninitialized variable value. So it would be acceptable for an optimized compiler to pretend that X was initialized as 0, just to execute statement 1 in the loop and return to 0. That would be an acceptable optimization, an as-if rule that would work. It would also be acceptable for a compiler to say X is a 1 and only run statement 2 and return a 1 out. So this is the kind of shit where the constant propagation lattice gets this funny state going, where because X is uninitialized, the compiler, the optimizer, is left with a choice of only executing statement 1 or only executing statement 2. He can pick and choose whichever one he wants. Both are valid interpretations of this program, which is reading an uninitialized variable.
Is there a short link for the doc, or can it be emailed? Sorry to bother.
I threw it in the chat. I can throw it again in the chat. There's not a short link, but you can make one.
I'm just on a stupid
you came late, you didn't
separate hardware device. I'll figure it out.
So the takeaway out of this is that in the land of uninitialized values, you don't have a best fixed point, a greatest fixed point, or a least fixed point. You have choices here. Both of those are perfectly acceptable answers. So you get a best fixed point in the land of conditional constant propagation by, you run the algorithm, and he'll tell you that because X is top, as uninitialized, if I test for top, I don't know which way I should go, so I'm going to take neither. And so he won't execute either statement 1 or statement 2. He'll claim instead that X is top because neither execute, X is still top, I'm done, I'm returning a top. I'm returning an uninitialized value and executing nothing. That's the abstract interpretation that hits a greatest fixed point for this program. And it's a weird answer, and it comes out because you're using an initialized variable. And all bets are off as soon as you do that. It's like fucking same as the C program does if you have any undefined behavior. All bets are off, and go to hell, dude.
I would think in a new language, though, it should say you have a free variable. No, I'm not compiling.
You have nothing to do with the age of the language. It has to do with what you do with the semantics of an uninitialized variable. Usually, in the land of Java, you just initialize it. No one tells you anything. It just secretly puts a 0 there. He says, hey, you really meant X equals 0, and now I'll go to town from there, right? That's your default initialization. As soon as you got a 0 there, the program's well-defined, and the optimizer cleans it out and says, yeah, you just want statement 1 and return a 0.
For properties, but not for variables.
I'm sorry?
For properties, but not for variables. Variables are not initialized automatically.
In your language, maybe they're not initialized, in which case you would get a complaint from the compiler that says you got initialized.
Talking about Java.
How the primitives in Java are initialized and have default value. I believe they
only
have
for
default.
fields.
In
Just for
fields, they're all initialized to 0. You're right. And local variables are not. Yeah, you would get a complaint out of the compiler, not initialized. Yeah. If this were, I can make the same thing out of an instance field, though, and it would be uninitialized, except that Java would secretly stuff a 0 in. So this is a language implementation, common optimization problem that you deal with in a compiler. What do you do with this kind of shit? By fiat, you just say, no, I don't take uninitialized, and that's a better answer. As soon as I'm not initialized, the problem goes away, program's well-defined, and...
Or at the very least, I would try to make that excessively clunky language that says, no, for serious, what I want to do here is read a bunch of uninitialized memory, because the thing that I'm doing is attacking someone.
Right. The problem is, as soon as I read uninitialized, right, I'm attacking somebody. I'm getting something else previously left behind. This is all security holes start this way.
Well, Itanium had not a thing.
No, that's different. That's a poison bit. Poison bits are well-defined. Just like nan and doubles. They just had nans in a more general case. They carried a 65th bit with every word. And
does anyone have a use case here for reading uninitialized memory that's not like Heartbleed?
Is there a purpose to it or reason?
Yeah. Why would someone want to read an uninitialized memory?
Well, usually they just have an algorithm that doesn't care, was easier to code that way because they were doing something else. And on the first pass, it just read what it thought was the prior thing, but it didn't care, and it just went forward. In deep learning neural nets, there's a hog wild variations, which are strongly normalizing starting from random values. And so they can read uninitialized and still normalize and get to the correct answer, but that's an unusual algorithm.
HotSpot is the one that has race conditions on purpose, right?
Yeah, race
You
conditions as
basically
well.
use stochastic gradient descent, and you can basically update the same cells
Right.
memory on purpose,
Yeah.
which is amazing.
Yes.
Yeah, who cares if you have race conditions and stochastic gradient descent? Like,
Yeah.
Yeah.
it was stochastic already. That was the first word.
Yeah. So it works, and then every possible compiler on the planet has any sophistication complains at you and says, no, don't do that. But it's fucking fast. I implemented it. It's good. You know, it was a H2O deep, whatever machine learning company. We did hog wild. We were crazy. We didn't do it on GPUs because that was just coming out that you would do this on GPUs. We were doing it on x86s across a cluster. So all your 20 core and 64 core machines would all run hog wild each individually, but then they would share the underlying matrix as fast as they could over the wire with each other. It was a crazy ass distributed version of hog wild, and it worked fine. Stochastic descent for the win.
I mean, that's kind of how science works in general. We have lots of people doing experiments in highly mistaken stochastic ways, but on average, we're moving toward truth.
That's a good point. I like that. That's a good answer. So then
and here now and then
about constant propagation and lattices. Is that like sorted out? That was typically, I was targeted at Max there, but I don't know.
Yeah, Max,
Sorry,
what
I
is
spaced
your
out.
core?
Did that answer your question?
The lattice explanation earlier?
Yeah.
Yes, I think I have a better understanding. I'm getting vague recollections. This was like, what, 2016, I took a compilers class, and the whole time, I hadn't taken the programming languages class, so I was like, what the fuck is going on?
What
time.
was the most interesting thing in the compiler class? You learned that?
This is my first exposure to SML, so that I used OCaml, and then SML was like, all right, you get nothing.
Okay,
no,
not the programming language in which you implemented. What concept did you find most fascinating?
First time you see OCaml, that could be the most interesting thing.
So I don't remember much because I was just struggling with the tools. Like, I was like, what?
Yeah, but something has to stand out. Something has to say when you see it in that this is really cool.
The thing that stood out in his head was struggling with the tools.
Like that class.
We had a tools discussion, so yeah.
Don't say parser generators, please.
No. We used MLYAC, and that was horrible. I don't want to go back to that. But
you use parser generators? No.
Okay, the point of that class was we couldn't do that. Like, it was a bad semester. The TA quit. Like, none of our assignments got graded. It was a whole thing. But I think the class I got the most out of was the programming languages class that followed. And I think formalizing a lot of the stuff that's like, okay, you have a type environment and you blah, blah, blah. And then going ahead and implementing it in ML was a really good connection where it's like, okay, this is the big step. I call the function eval on the left and the right, and holy shit, like, that was cool. I really didn't like writing the thing that I didn't like was writing the big step, because it's like, am I right? I don't know. I'm gonna find out in like a week when I get my LaTeX back, with a big red X.
Did you learn type systems in the compiler course?
We did a systemf type thing.
Systemf, okay, that's cool. So did you like it?
Actually, not systemf. It was like the more basic one is that just Hindley Milner? I guess it was just
Hindley Milner. Yeah,
Hindley Milner. Yeah.
Systemf is more powerful.
Yeah, we didn't get there.
But undecidable. Okay, cool.
Yeah, Matthias Feliason had just come over from Germany, lied to get into the US about his academic credentials, and was teaching at Rice University when I was there. So I took classes from him on shit, and he was just heading down to the systemf direction. Wasn't there yet. And so I got the whole evaluation, functional programming language typing thing from Matthias when he was in his youth, and extremely, I don't know how you call it, as a personality, I would say angular. He had a lot of sharp edges in that personality.
The artist was taught by Kathleen Fisher, who is very formal semantics heavy, because that's what she does.
Yeah.
And so the whole time I was like, fuck, oh my God, I don't know.
Yeah.
I'm not cut out for this.
Yeah. I'm not the formal semantics guy, but I've done enough of it that I can kind of grunt my way through it, but it's not my thing.
So there's a pair of speeches that stood out to me. In my curriculum, the operating systems course and the compilers course was co-recs. So you had to take them at the same semester. And they were taught in the same lecture, 1 hour apart, one right after the other. And the compilers guy gets up there and says, the thing you need to understand about compilers is that operating systems are unnecessary. The point of a compiler is to take your source code and produce something that a computer can run. And it should transform your program into something that the computer understands and can run efficiently. And the only reason we have operating systems at all is because our compilers are insufficient to the task. And then 1 hour later, you go to the operating systems class and he goes, the thing you need to understand about operating system is that compilers are unnecessary. Our computers should understand the things that we are saying. You should give your operating system the source code. It should interpret it and translate it for the hardware that it's on and make everything run nicely. And they basically went through that the entire course with how the key to a good compiler is that you don't need a runtime, and the key to a good runtime is that you don't need a compiler.
Yeah.
They had fun playing with the lectures being paired like that.
I mean, it sounds like everybody needs a runtime, and to some extent they agree on that. Whether the runtime is like the hardware or
you have to have some hardware, but you're doing embedded systems for the missile. You don't need a whole lot of OS.
Yeah, why isn't our runtime x86?
Because
the fact that I compile something for Windows or for Linux or for Mac is weird.
Like virtual memory. People write bad programs, so you have to have virtual memory protections. So you want virtual memory.
I believe they got started
threads,
from different type of. Okay, threads. Yeah.
Sorry.
No problem. I believe they started from different paths, and that's why they have to evolve some abstraction mechanics from the underlying hardware. And that if we got started with x86, 68, 64, no problem, then we still run that. We won't have different architectures, I believe.
So basically, what we're advocating for is I don't know, a language that came out like 30 years ago, Java, or I mean WebAssembly these days, or whatever the latest thing is that you write it once and it will magically run everywhere.
Yeah, Java tried really hard to do that, and actually kind of got pretty close. That there's a set of things that was much broader than anyone else at the time for Java would run well. It wouldn't do embedded systems. You weren't going to do your elevator control logic under Java.
In ways that are still paying dividends today. Like at work, when we're doing experiments on can we switch some % of the data center from x86 to ARM processors?
Yeah.
And the fact of the matter is, a lot of our code is in Scala and runs on the JVM, and you change the architecture under it and it doesn't care.
It works.
And that's kind of amazing.
Yeah. And
that's the benefit.
Yeah.
To write in a high level code, higher abstract level code.
That was the goal.
I mean, what was it? 15 years ago, maybe more now, I had some crappy Sony Ericsson phone. This was way before smartphones, when GPRS was still fast. And it ran Java for a whole bunch of stuff, and that was the bomb, basically. Yeah, I think Java did quite well. I think ultimately, probably one of the issues, at least for the web side of things, is that you had to install applets and whatever software for that. So it never really took off. Yeah, and I think for embedded stuff, I don't know how many organizations sort of invested in getting Java there, but
lots.
I suspect
Java as a language.
Java on heavyweight data center servers and on this YubiKey. Yeah, right.
Well, nowadays it'll run there. Back in the day, people tried hard to squeeze a JVM down, and they had issues, and the resultant JVM had issues. You could get into these little things. At the time, they were like 32K or 64K, and you could kind of sort of squeeze it down, but kind of really wasn't worth it. These days, I bet you that little thing you just held
I think
up.
there's 32 megabytes of storage on a YubiKey these days.
Yeah, right. Yeah, the thing you held up is going to be many megabytes, and a small form factor JVM should kick in into a couple of megabytes and be okay. Like the original HotSpot did record-winning spec JVM scores in 64 megabytes. So that was plenty to run interesting programs.
Cliff, I heard the original designs for Java kind of put like a lot of the math in the math space, kind of thinking that that might actually be in limited environments, maybe be ejected. Like, hey, we just don't need to do sign computations when we're putting Java on a little thing. So I had heard it was kind of walled off, ready to be ejected at moment's notice. Yeah. Did they ever end up kind of doing that for small environments?
You're talking about Java ME micro edition. Which was the officially, here's how we ejected. Eventually that got thrown away because machines got so big, you didn't need to do those slicing, dicing.
Sure.
But the original thought was, we are running this on embedded systems as well as big servers. We need to eject features. So yeah. Math.sign and math.cosine are in the math library because, I can eject them if I'm running a DSP chip doing whatever.
So I learned something about math this week. The results that you get from doing min or max functions in IEEE floating point is dependent upon the order in which you give it the arguments to min and max.
Yeah, computer math's never been associative, commutative, and any of those fun, good math things. IEEE gets really close.
I mean, I get it for multiply and add, but I figured max was pretty deterministic function.
Oh, that's interesting that you don't get on the order though. I'd have to see what arguments do it. Like you got denorms and you got infinities and.
You care about preserving order of your arguments if you are implementing stable sort.
Yeah.
Because even if the elements are equivalent, it doesn't mean they are equal.
Right. I'm trying to think of what is a set of types, what set of arguments to max where the order changes the result, but I can totally believe they exist.
So nan is not greater than or less than any number. So the max of nan and a number is nan, and the min of nan and a number is nan.
Yeah, but that's
the max of a number and nan is the number, and the min of a number and nan is the number. So whether you get nan or the number out of the maximum of nan and a number depends on the order in which you passed them.
I would have thought, okay, fine. I thought you just get nan out in any case.
I thought the IEEE 754 spec was defining the results for these kind of operations explicitly. So I also thought this was consistent.
Yeah, it does. So, but I think, I don't know if it defines max, it defines comparison. If I compare nan and x, I compare x and nan. Right.
Yeah, I guess the core question is whether max is defined in terms of total order comparison, which is chapter 5, section 10, or the normal comparison, which is chapter 5, section 11.
I would have said max is not defined by IEEE 754 directly, and instead max is defined by the user application, which is Java's, bytecodes for max, which is if x less than y, take x versus taking y, which now has a comparison, which takes the left or the right. And if nan appears left or right, you get nan or not the nan accordingly. And it has nothing to do with IEEE 754. It has to do with the Java implementation of max. That's my guess. Now I have to look it up because, what the hell.
But that nan thing and the SQL null are two of the biggest stupid mistakes in the history of computer science.
Which one?
Nan and IEEE 754 and null and SQL.
Oh, null and SQL I'll kind of agree with. Nan I don't agree with. This was it went in for a very specific and I think a good reason, which is naive but well-meaning programmers would accidentally do something that was not sensible, and you wanted to not let them get trashy answer out, but give them a specific you screwed up. So they at least knew they were getting garbage out as opposed to just getting garbage out. And then that's where NAND came from. You did a stupid thing. You got
but the
garbage.
result, but the arbitrary rules about, if you compare a NAND to a NAND, it has to return not equal. And if you compare it for not equal, it has to return equal.
But looking at the links in the chat, it appears that the correct behavior here changed between IEEE floating point in 2016 and the 2019 version of this.
Well, this is not something I've seen, so I'm curious now.
They changed the definition of floating point in 2019.
Wow.
The latest standard I read was the 08. So
yeah, in the 08, the max is not explicitly mentioned, but I heard there were clarifications and suggestions how definitions in the spec are applied to languages and the standard libraries more directly. So what's the result?
Well, they handle the case of NANDs and min and max to make them associative.
Yeah.
And commutative or whatever. Yeah, they do the right thing.
So it seems like it was undefined, and then they defined it to make min and max monotonic. And then they undefined it in 2019 to be like, oh, there's too much code out in the world that doesn't do this. We can't actually mandate that min and max are monotonic.
Yeah. Well, every JVM on the planet is just going to say, yeah, we're throwing min and max into the optimizer. And it's going to do optimizing things with it, which is, it's not. It's going to preserve your order of comparisons just the way the bytecodes do, which is going to be non-associative. Yeah.
Anyway, it just goes to show you that standardizing things are hard.
Yeah.
I've heard countless people be like, I'm going to make my new language and there's going to be no undefined behavior. And it's like, no, you're not.
I'm going to try really hard, but yeah.
Oh, I'm all for trying really hard to hammer out the undefined behavior.
Yes, exactly.
But this is a multi-generational effort.
Yeah, sure enough. Oh, I'm sure the next undefined shows up a little bit later down the road. It's all good. Ultimately,
what year was it that Java got its memory model?
I'm sorry, the Java memory model about it?
What year did the Java memory model appear?
I implemented what became the memory model spec in Java 5. I was busy coding it up in the 2000 break, 98 to 2000. The discussion was already hot and heavy and going strong by 99. And by 2000, 2001, I was busy doing what we believe would become the final spec. So I don't know when the published final spec came out, but Java 5 had what effectively was the final spec. There were minor tweaks and bug fixes, but minor. I think there was a one more game played with final fields that maybe got sorted out in a dot release after 5. A lot of the libraries were playing catch up for a while. Even with knowing what the spec was and writing code to it, people screwed up and had mistakes and didn't do things well and whatever. So libraries took a little bit longer to get. The concurrency libraries in particular were another go round. One of the major holes was that there was no CAS. So you had some misc atomic to get your CAS, which had to have it for all them, concurrent algorithms, with no point in having a memory model if you didn't have a concurrent way to do concurrent algorithms. So eventually you got Java Lang concurrent or Java util concurrent atomic, this and that, whatever. But the memory model basically came out in 2001, 2002 as published by Java 5. And then we discovered all the people who had, undefined behavior for having misused compilers memory model for years on end. Yeah, Azul ran through. That was another one. I switched to Azul. We were running Java under simulation on the new Azul hardware being simulated because we didn't have any hardware yet. And Steve Goldman was working on the Itanium port of the core runtime. I did the compiler Itanium before I left Sun, but he was doing the core runtime. And Itanium had a much bigger model than x86 or Spark in total store order Spark. And that meant that there were bugs in the JVM. And I was finding bugs in the JVM under my completely software simulated with every kind of, racy Azul hardware and Itanium running really. And Steve Goldman and I were swapping race conditions in the core JVM implementation for the next year, basically. we went back and forth and back and forth. It was who could find the next race condition, and then we chatted up and why is this a race and why is that a race and how to solve it. And we both go solve it and go back to doing our thing. It's like, Sun as a company was giving the evil stink eye to Azul, who was giving the evil stink eye back at Sun. But the engineers under the hood, we were just like, God, just make this shit work. That's what it was.
I hear the same thing for the ISPs. The director to director level clashing while simultaneously the engineers are handshake negotiating BGP involving way more email than you think should be involved in BGP handshakes.
Yes. We're going to make this shit work. You guys quit being stupid, whatever. Fine. You stole my dude. You can't have him. Hey, you stole my dude. What? We implemented this first. We got this great extension, and you're like trying to sidejack it. No. Whine. Oh, guys, shut up. Just make this shit work. Fine. Been there, done that. At least on the implementation, make it work side. Yeah. All right. What else?
So I'm curious if people have opinions of putting format strings directly in your language so that your compiler can do a bunch of optimizations and be like, hey.
And type safety checks. Java C does that now. If you do string system, whatever, string.printf or system out printf, and you screw up your format string, you'll get a compiler error. It's kind of exciting.
But that's mainly because it's reading. I'm just thinking more, so we have the sort of traditional printf. I've got a bunch of like %s's, and then I give you things to stuff in there. And if I give you an integer where I told you I give you a string, you can get mad at me.
Right. So the compiler can't tell that in all cases that the string is well formed. So when it can't tell, there has to be runtime tests. You can fail at the runtime because your compiler, your values you're passing in and your format string are not well spec'd. However, if you do pass in a constant string, he can tell you ahead of time. And that's a different problem because now the language changes according to, you get its compile error if you pass in a fixed format bad string, and it's not a compiler error if you pass in the same string, but via some indirection, so it's not an obvious textual string. But then you get the error at runtime.
So like in Python, I can actually put an F before the quote on the string.
Yeah.
And that means now anything I put in parentheses is Python code. And I can put arbitrary code into the middle of my strings. And now I have that sort of PHP style-esque, I've got code inside strings.
Oh,
but then in theory, I could put a string inside the code inside the string and then code inside of the.
Yeah, I'm sure somebody does too.
Yeah. In Scala, you can define arbitrary interpolation strings.
Yeah.
You just define a function and you use it like use it.
So how much can the compiler help with these things to make sure that the code inside of the string inside of the code inside of the string is actually formatted meaningfully in the environment where it's
easy because you had a string already in your face. So your compiler can now interpolate the string. When he gets to the code, of course, the code has to just be the code. He runs this normal code thing on the code, and it's all great. And then he gets a type out of the code because he's a type, and that's what he does, right? He gets a type system and says, yeah, this piece of code is a type. And now he has a string, and he has a type, and he can validate the string format matches the type. I think that one's easy. I mean, it's not easy. It's definitely a pile of work, but it's not.
But if I know that that code is going to turn into a constant string, I might be able to constant propagate all the way through it and just give you a constant string that I calculated at compile time.
Yeah, totally. And I know there are certain like C const expers and shit like that. Like you can demand that behavior happen.
Yeah.
Like it's an error at compile time if I can't constant fold this entire thing away.
So can that replace a macro system?
Does anyone use Kotlein's string formatting? It's like it's similar. I think C# does something similar. I think our style came from Kotlin. But basically, you basically drop code inside a string and it executes.
Yeah, does Scala does that? So Scala does.
Yeah, I think Scala is similar.
It references the variables with a $sign. If you want to insert a code, you reference it with a code block, $ in the code block, and regular Scala, and that interpolated into a string.
And if you want to have a $in your string, you have to backslash it or something.
I don't know how the game works with multiple doors. What exactly would it tell you?
Yeah, I think the difference is that in Kotlin you have the interpolation by default, and in Scala you have basically this kind of extension method on some special string formatting class. And you basically there is in the standard library there is a string formatter defined called S, and this means you can put an S before the opening quote, and then the string gets interpreted based on the method implementation of that method S. And conveniently, this method S is implemented as a Scala macro, so it happens at compile time. But you can basically take your own letter like X, write a method, either like a real method or a macro method, and place it in front of a string and let it do your own stuff.
Can you? I put a block in the Google Doc. Can you edit it and show what you're talking about?
Sure. In Scala, it's I think it's this for the normal formatting, and you can also do like the printf style formatting where you can say, okay, I have this variable, but I also want to like no idea, just use the normal. I'm not sure if this is something like this. And actually for like some random script which just needs to do some console output and wants to align things, this is really, really convenient because you just write a text, tell it, okay, fill it up to like 30 blanks and be done. And it's really convenient because it's all checked at compile time. So if you make mistakes with the formatting string, it can just tell you, because also like the F thing is a Scala macro and just run it.
You can write macros in the style too. You can prefix it with code. Like there are some string interpolators, and there you write macro as you interpolate it, like it's a string.
So I didn't get that.
You can write a macros which work just like the interpolation in string. You prefix your string with code, like something like that, and inside you write the Scala macros. There is some framework. I forget what the framework was.
But they're doing that at compile time, not calling eval.
Yeah, they also it changed I think with the new version, but it's something like def, then there you have like string parts, which is like this, and like the variables.
Get the link to the Google Docs.
And then you have something like macro f impl, something like this. It's and then you basically need to attach it to the string formatting class. I can have a look. I'll just jump to the standard library.
Where? Oh, I see.
Give me a sec.
Thank you.
Gotta go. It was fun, guys.
In the chat now.
See you next Friday.
Yeah, I was thinking, Cliff, you mentioned earlier that you probably didn't need a macro system because you could just manipulate strings of code and then call eval on them if you had eval.
Yeah.
But to some extent, it feels like you're going to lose a lot of the power. It might make sense to have specifically this is a code string as opposed to a normal string.
Yeah, I've screwed around a little bit here. In theory, I haven't done it yet, but our plan was to put interpretation in the code and probably %, not $, and it would trigger code up until the next lexical end of code. So some function there or a % variable name. Having the % be printf formatting following, I haven't thought about. So there's two actual, the Scala one has actually two special characters, dollar for starting your code and percent for doing your formatting. And I kind of like that. So I might flip around and pick it that way.
I kind of like Python's idea of putting it in parentheses. Be like anything that is not in this particular type of parentheses is.
I put too much parentheses in code too often for me to want to have parentheses be a special escape.
I see.
That's my theory. Like, how often I put dollars in code?
Wait, hold on. Doesn't Python use curly braces for f strings?
Yes.
Someone.
It's the curly brackets or the parentheses in format strings.
I think it's Swift that uses like backslash parenthesis to start it or something, and then normal parentheses.
I added the links to the Scala
yeah,
library part and the compiler part to
the Scala framework I was just saying was a quasi-quote. That was the framework that let you interpolate the macros inside the string. I will throw a link.
What was it Lisp used to use? Caret and tilde for?
In the realm of language design with a weirdness budget, I claim dollar and percent are the least weird for special escapes.
Yeah. After that, it gets really hard to argue that it's sufficiently well understood. It's like in many parts of the world, like they don't. There is like not enough. It's how is it called? It's like everybody calls the same symbol something different. It's like with all the accents, they are called it something different in French and Italian and English, and then try to find some squiggly symbol, and like everybody has a different name, and then we are supposed to like understand what it's doing.
So the question is there an emoji symbol for fire escape?
Yeah.
I will say one request I have for people designing new embedded languages like that. If you're going to have your character and then you're like slash this character for escape, but then I can't do slash. So people are like slash to do a slash.
Okay, now you're writing a regular expression.
Don't escape your slash character with slash.
Yeah.
Because that means as things end up nested, you get exponentially more slashes. At the very least, give me the option to be like /e is going to be enter my escape character here so that I can at least grow linearly if I'm 10 deep. I don't need 1,024 slashes.
Let me throw in this comment on a regular expression in the guy there. Strip alias numbers, and then the quote // bracket 0-9 close quote star // what the hell's going on? So I claim regular expressions are a horrific idea, and I should never ever use them. Is that the discussion about what it is and why it is, and the count of escapes that have to happen or not happen, means that it's just not worth it. This is like a really tiny regular expression too.
Yeah, it's powerful and it's mathematically valid, but it's incomprehensible to humans.
It's incomprehensible.
At least this one.
So your argument is that the semantics is useful. You just don't like the syntax that we've chosen.
I don't understand. Right. It's a minimalistic syntax that was all great for defining the theory. But when I practice a regular X and I look at somebody else's reg X, as soon as it gets as big as what I got here and goes on, it's like, it's going to take an hour to break it down character by character. I need a compiler to parse the fucking regular expression for me.
It's a write-only language.
It's a write-only language. Yeah.
So I would like to, there's a friend of mine wrote a library in Rust for building regular expressions. It's a language whose value type is regular expression. And you can have functions that generate regular expressions. And it's pretty legible. You can have like an IP address. You say like, these are the blocks and blah, blah, blah. I don't have access to the chat, or I can try typing in with my single finger on this touchscreen.
Somebody's putting in a regex101.com link in the Google Doc.
I'm going to send a link in the chat to this library. It's pretty cool.
is. Didn't show up. Anyhow, I like escapes and strings.
What
Don't
was
like
the
regular
name
expressions.
of the library? What how the library is named?
I can see him furiously screen typing.
Yeah, I know.
All right. I couldn't be bothered just typing github.com, but that's the library. It's called Remake. And I don't know. It came as the result of sort of an evening of drinking and, you know, shit talking regular expressions.
Okay, there's the linked version in the doc. Writing an attainable regex. Yes, they lack tools for abstraction and modularity. This is correct. I claim your language is as big as it's twice the size, because that's the point. It's twice the size of the regex, but maybe it's correct. Maybe it's the right answer. Yeah, maybe.
Okay,
Right.
how about parse expression grammar? It's basically a regex. How can you get away with it? Not writing
I don't
regex.
write my parse expression. I don't write a yak or a lexer thing.
Yeah.
I mean, it's
Yeah.
more than basically half the tools you use for those actually do take regex.
Oh yeah, yeah. And I have a BNF for AA that's pretty straightforward, but I wouldn't want to.
The BNF is gold standard, and extended BNF is gold standard. Yeah.
Yeah. It's probably eBNF. I don't know. So there are tools, there are online tools that'll take grammars, by the way, and let you put language pieces in, and it'll tell you if it passes your grammar or not. It's kind of cool. It was a fun. It'll also tell you if your grammar is like LLA, LLAR, LR1, LL2, yada yada. That
Get a
kind of
run.
shit.
This was fun.
Here, actually, I can pull that one up too. So we're doing grammars. Look how we're doing grammars.
Yeah, I think we discussed it on this call like a year ago.
Maybe. I found it useful. There's more than one of these things. I'll throw this one in the chat here. This is A1.
But is there a good way to check that your parse code actually implements the grammar that you said it does?
Yeah, well, there's like ambiguity questions. Like I use colon to start types. I use question mark colon as a ternary operator. Is there any ambiguity in expressions involving question mark colon operators where I'm also casting the type annotations things, right? And you can get places where it's legit to have two colons in a row, colon, colon. And is this ambiguous and whatever? So hey, throw it at the grammar checker. He'll tell you something stupid about your grammar. What was I looking at here?
I will say that's one point Lisp gets is the grammar is pretty unambiguous.
Yeah, grammar straight up. Yeah, I was looking at plus plus and unary operators. Like plus plus is a postfix only, and there's some unary operators. And can I get myself in a wedged situation if I have unary plus and bang signs and variable followed by plus plus and bang bang or whatever? There's a bunch of places.
Do you plan plus plus as an operator?
Which one?
The plus plus operator.
Yeah, I have it as a postfix operator, and I might do prefix version of it as well. I don't know. What is the rosy pattern language? Oh, what is this? Ah, it's a replacement for regexes. Gotcha. Yeah, fine. And some sort of element for doing regexes, right? It produces a regex. Okay, fine, cool.
Yeah, but in the end, I wonder it's like if you have like this kind of ambiguities and have to think about it, whether the grammar works the way you intend. It's like in most cases, I think it's just leave it out. It's like it's 2021. Who needs a ternary operator anymore? Who needs unary operators? Like just
Well, he doesn't have an if, so he needs his ternary to write the if.
I like ternary operators. I use them all the time in every language I write in.
Yeah,
Because I find that terse syntax leads to fewer bugs. And you're like, no, it can't be. And my experience, backed up by a fairly extensive test, was that people who wrote code that was fluffy, had a lot of vertical spacing involved, got yes, and Cameron's one of those. I didn't test Cameron, so I don't know. This was in the land of HotSpot, where I looked at 20 guys output in the code management, code mangler at the time, and their bug rate. And the answer came back was that there was a bell curve on bug rates. There was a rate at which you wrote code, and there was a fluffiness, a vertical spacing factor kind of thing. And individuals, the bell curve was sort of independent of programmer speed. Programmers ran on an exponential scale. I was exponentially faster than the slowest guy. And there was a clear factor of 2 between people on the team of how fast they wrote code, which meant that you could write code fast and have just the same bug rate on the bell curve, percentage bugs per line of code, but that you wrote more bugs because you just wrote more code. And the bug rate was independent of the fluffiness factor, which I also looked at by stripping out comments and white space and shit and vertically crunching and doing those kind of things. And the answer was your bug rate per line of code was the same, whether you wrote fluffy code or dense code, but you got more shit done in dense code, but you had the same kind of bugs. So bugs per unit of functionality were lower in dense code.
I wonder what the direction of causality is there. At least in the code I write, I tend to write pretty dense code when I know what I'm doing.
Yeah,
and the more confused I am, the more I break it into tiny little pieces and put lots of comments on the side to try and think through my problem.
And maybe that's the causality issue. If you know what you're doing, you wrote the dense code in the first place. And maybe I just picked up that one. You know, I don't claim, I claim I got correlation.
The counter argument I'd offer is that down the road, that dense code is harder for both you and everybody else to read.
It's not harder for me to read. That's the issue. I don't understand. I mean, I understand why other people.
Okay, let me substitute understand for the word read. Right. The denser it is, the harder to see the structure of it. I find.
So I claim I get really good structure too. That's part of the dense code. I get tight code with good structure. There's not unstructured things floating around it.
And I think you need to, going back to the ternary operator specifically, I think you need this if you have a language with if statements, but without if expressions, because otherwise you're just gonna repeat code. I think this is a common anti-pattern that I see when someone writes if condition, return X, else return Y. You are repeating return. What if you make the mistakes there and just type Y, for example? And if you have a long block instead of return X and similar long block instead of return Y, then you are repeating every single instruction in that block. So ternary expression is a strict improvement in code readability, maintainability, and correctness here. But if expression could help as well. So if you have a language where if here is an expression, then you can of course just use that.
I guess that's my point, questioning whether like the improvement from ternary operators really comes from being able to write a question mark instead of a then and a colon instead of an else keyword, or if it comes from that the ternary operator is an expression. So you write better code than in languages where if then else is a statement.
Yeah.
And I think that's what that's what I would argue for. Is like, of course, it's like this thing needs to be an expression, but I don't think like one needs to have like if then else, a ternary operator, and pattern matching. It's like the 3 things that do the same, have one designed in some coherent, consistent way, and then you don't have to worry about too many grammar or parsing problems along the way.
Yeah, that would be correct if they can all boil down to the same thing, because if an else and match expression doesn't boil to the same thing always, and this is a matter of efficiency.
Match expression does more stuff. I'm with you that the ternary operator I use because it's an expression, and in C and Java I don't have it as an I don't have if then else as an expression. I have ternary operator as the only expression choice. So in the land of AA, I'm open still to the concept of having an if expression as opposed to only a ternary. I'll have a ternary, but I could have an if expression as well. That one's sort of an open question for me.
The ternary expression, I believe, it condenses more things by being an expression, and you can just say it in one line.
You could do the if then else as an expression in one line. Well, for languages that support if then else as an expression, it's an expression.
It's the same thing. Yeah.
Yeah, it's the same thing. You just replace question mark with if and then with a colon, and you're done.
Yeah.
More often than not, it's about the concept you express and the syntax you express. That's why there are many arguments about the syntax, but the underlying understanding of the concept is really unclear. How to say, should I put it?
Yeah. And when I go play the game of dense code, having an if expression is part precisely of the clear, concise concept.
Let's take Haskell, for example. The Haskell takes write more code with the fewer keywords, fewer concepts, but the concepts are pretty dense to understand and put the cost up front to understanding it and then using them in correct way.
Yeah, isn't that a bit arguing that Haskell code is better because those people who don't know what they are doing can't even manage to make it compile?
So okay, let's put it that way. The Haskell folks are always there decades here, but their concepts are pretty hard to understand up front. And you see a code that looks like a Chinese, and you don't understand Chinese. You scare, and the not knowing part makes them better in other side. I should say. The more not understandable things they do, the better their status goes up. At least in my opinion.
Yeah, maybe it reads out the weak or something. I mean, it's like you can't imagine. I think for OCaml, some company just invented a different JavaScript like syntax, and I think you could do the same for Haskell. And
you can use the same concepts, but that's why the newer languages, if they strive for adaptation, they write something that is the more languages are established upon like object-oriented design or keys, classes, and more concepts that are familiar. So it's easy to ship over to a newer code base, and there is nothing prevents them to include the concepts that are pretty dense. They do much more things than they used to, but they're harder to understand. So the people just may not ship over. This is my opinion, of course.
Yeah, I think it's like also it's like Haskell is not the youngest language anymore, and there's just a lot of stuff. I think from even if you just look at it syntactically, which you would probably do differently if you created the language in like the last 10 years or something.
Elm uses the Haskell typer, but it's getting modern
completely
syntax.
Different.
Yeah, modern syntax.
Yeah, so yeah.
Elm certainly has a lower strangeness budget than Haskell does.
Yeah, that goes with the history. The older you get, the stranger you got because you're doing so far in the past. Yeah.
Yeah, everything pre-Algol 68 looks crazy.
Yeah, that's a good one. Anyone here use RPG1, report program generator? No? I'll tell you, there's a strange one.
If I need to generate a report, I'll use awk.
Exactly. This is IBM's answer for non-programmers to write reports from the 60s. Fixed format, punch card only, columnar language, weird as shit.
But I think this language convergence is not even that bad as long as there's still experiments on the side. I think it's like
so all the world becoming an x86 is bad, but all the world becoming C-like syntax is good.
I think even we're moving a bit away from that. For instance, like the discussion about like type name or name colon type, it's like the second one is winning, even if like C and Java did it differently.
Yeah, I'm with
And,
the thing colon type.
Yeah, and so I think there is some progress made,
Okay.
and I can't complain about that. And I think like
you call it your progress too.
Sorry?
You called it progress. You didn't call it as you know, oh, we're going backwards or screwing up. You said, hey, it's progress that we're all going thing colon type.
Yeah, the colon thing is it's like if you have a look at it's like for languages without generics, it doesn't matter. But as soon as generics get involved, the colon syntax is superior, because with the other syntax, you have this issue: where do you place the declaration of the generic type? Because the return type with the C-style syntax happens before the method name, and that gets ugly really fast. And you even have so, because basically at the simplest level, you can describe generics as just another parameter list that has types instead of values. And that means you can have like, okay, I have the method name, I have the type list, I have the value list. And this works perfectly fine with this colon syntax, but not with the C-style syntax. And I think that's a really big point for preferring that syntax.
So for generic syntax, the land of Java used the angle brackets.
Yeah, that's also losing, so also progress. So
okay, and other people have done other things. What do people prefer for that? You have a
not angle brackets. No.
Okay,
square brackets.
Square brackets.
Square brackets.
Yeah.
Space, like list of string is list space string, or list round bracket string, or list square bracket string.
I find it hard to like. I think that is like, it's preferable to have like a different symbol that indicates where things start and where things end. So yeah.
Whatever syntax you choose, I think it should match your syntax for functions. If I'm saying this is a function that takes an int, the type that is the generic, well, this is a list of int should look like a function that takes an int.
At function application or function definition?
At the definition of the type.
You mean that the definition on the use of the have consistent?
I would say the type list of int is the function list having passed in the type int.
All right.
Shouldn't this
so I
lead
put in
to
the
confusion?
docs some options here. Tell me what you're you know.
In the Google Docs thing.
Yeah, in the docs. The last.
Can I put just like, how do I do a plus or something? Everybody can just vote by adding another plus for himself or herself or something.
Fine. So you want square brackets.
Cool.
Somebody wants round. Somebody wants space. Oh, someone says no. That's Haskell syntax. Okay, yeah, there's a comment for Haskell syntax, but not a plus or minus.
I really appreciate that the comment that says Java is commented with slashes and the comment that says Haskell is commented with dashes.
Oh yeah,
that was a nice touch.
Yeah. Well, let's see. So far we have one for the blank, one for the square, and one for the round, or two for the square, one for the round. So that would be pretty much an even distribution here. I claim well within standard deviation of error for a pick one at random.
But I think that's also like goes back to the point of leaving things out of the language. If you like use square brackets for generics, it gets really
what about arrays?
We really incentivize using special syntax for arrays, which is like a good thing. It's like we don't want to have like a single type which gets special syntax everywhere. It's like array is just a simple type.
Generic is just a parameterized type. And we have syntax for passing in parameter lists to things. That's how we call functions.
With the round ones? With the round one?
Yeah.
Yeah.
Why should a type that takes a parameter be different than a function that takes a parameter or anything else that takes a parameter.
I think I'm totally with you in languages that have dependent types, or where at least the distinction between types and terms is not so great. But I think in languages which like are not that powerful or complicated or whatever you want to call it, I think it still makes sense to have this distinction, because they are really different things in a lot of ways that non-dependently typed languages still haven't bridged the gap between.
Well, I don't like dependent types because they have problems with termination and typing and shit.
Yeah, but you can have a termination checker. The termination checker can tell you if the expression will terminate and not. Yeah.
Yeah,
That's-
I'm like
That's it. That's why it was the do not get hung up. The termination checker will check for you if the expression will terminate. The dependent type will be resolved.
So here's another version, which is parens, but with colon, which is what I've been using for starting of a type.
Right.
Somebody
In general, I'm not sure that's a great syntax, but for AA specifically, where it's easy to recognize types because type names start with colons.
Well, map would be a type name in this context. If you, so you said map's a function that takes whatever.
That's an interesting idea.
So replace map with list :string, right?
Well, usually I would say we use uppercase letters for types, so they are easy to see, so you don't need to colon one.
Right,
Yeah.
right.
It's a matter of taste.
I'm using a simple grammar rule to just start a type, which is colon. Now I don't care whether your types are upper or lower case, but maybe coding smell, you want an uppercase anyhow.
Yeah, that's also something that really annoys me, that like some languages, especially older ones, have like random conventions for types. So like an int starts with a lowercase, but a string starts with an uppercase or something. Yeah. It's like I don't.
Lowercase came from C.
Yeah.
Which didn't have capital strings or capital types.
Sure. Yeah, sure. And I think that's something that newer languages should have done away much earlier.
Because on the PDP, I had to pay extra to get the uppercase keyboard.
So
I'm not sure if you're being facetious or not. It could be true.
I'm being facetious.
It would be the lowercase. The uppercase came for free. Lowercase came later.
You had to get the character set pack for it.
Yeah, right.
So do you see list as a type, or list is just a function from type to type?
I want to define a type which has the list-like properties of having a next field and a payload. And I want to put a generic type on the payload, so all the payloads have the same type. They're all strings, or they're all Persians, or whatever. Right, now define that type. In AA, list is not it's not a built-in type. I have to define a list type, but I can define a list type sort of trivially. But where do I put the generic for the payloads type? So I don't care it's called list or it's called whatever. I'm suggesting, or I'm asking the question, where would I stuff a generic type in a type parsing syntax? Like I have a parser's AA. Well, one of them is a type parser. It's a specific, it's not very big, but it is a specific parser for type expressions. Somewhere in the middle of type expression, I need to say, and here I'm having a generic type put in. And where do I put that, or how do I put the syntax for that? So I can't tell who's typing, anonymous capital here. I do functions with arrows. So a type of a function looks just like a function expression, except substituting parameter names for types. So I see, looks like Aaron's probably writing. So list is, you're saying it's a function as a type. You haven't declared list to be a type yet. That takes a type and has a next field, has to have a payload, which is itself a pointer to a thing. That's not the way you write the list type in AA, but it's getting closer. It's more concise in particular. Yeah, and list of type, right. So now you're kind of defining, you need a payload in there. I can go add one. and then go edit at the.
Right. So my thought is a function, and what the function returns is a type.
Oh, I see. You're trying to make a function type, and I can parameterize.
Yes, that colon at is the thing that is being returned.
Oh, it's a function type. Well, I still want to have a thing which has a payload, but has a value. I'm returning a type which has a next field, which is a list of type, and a value field, which is a type. That's an interesting syntax. That is not the syntax I would have gone through originally. I would just use allow you to have free variables show up. So you define type as your type name, as your generic parameter name. I would just let you do a free variable in a type expression and immediately give it a scope, which is of that type expression scope, and repeated uses have that thing.
Oh, is that different than what's here?
Yeah, because you had to put a functional syntax around the syntax of open curly type arrow in order to define a type variable type, a generic type variable. So I'm not claiming that what you're doing is bad. It's just different. And I haven't sorted in my head if it's like what I want to deal with or not. And I wouldn't need a next wouldn't need to be an arrow. It would just do a list of type. You got more syntax going on here than is necessary.
I see.
But like simplify the next expression here. Let me simplify the next expression for you.
Aha, shared document editing.
Yeah, shared document editing, right? So and you probably need some other piece here because I want to have an expression function, which I don't know. So you define an expression, a type function, takes type parameter, returns me a type. Okay, and returns me a type because it says the return value is colon a type. So it's returning a type. Okay, great.
You're saying next points to the next thing in the list. Next is not a function that returns you the next thing in the list.
Yeah, next. Yes, next is a type. This is a type expression. So next is a field. So the whole type for list is a structure which has a next and a value field. The next field has type list of type question mark. Yeah, you need the question. I didn't have the question mark. It's correct. List of type question mark. And the values of type. So that looks like a function which returns me a type, which is a way to define scopes the generic word type.
How will you recognize that list is a type itself?
Because the return
value is a type. That's got to happen at typing time. Like if this function doesn't execute at typing time, you lose.
Right.
This is not a runtime construct.
Right. And so the colon in the return value expression part has to be there, obvious to the parser. Like the parser begins saying, oh, this is a normal function. I have a normal function with a normal spiral args, a normal function arrow. I have a normal body. Oh, the body starts with a colon. It's returning a type. Fault. It must now go to the type parser, go back and reparse this as a type expression. And now list becomes a generic type that requires a parameter, and then you define it with curlies as a string to get you a list of string.
So for that parser, you have to look at so many through 3 tokens to understand how to parse it. Okay.
I do anyhow. When I parse an open curly expression, when I start seeing identifiers, if you don't have an arrow, then you have a no arg expression, and the identifiers are the body. If I see an arrow, there are identifiers. So I roll forwards until I see an arrow, or if I fail to see an arrow and I fail to see an identifier, I immediately go back and reparse it as a no arg function, and those identifiers are now expressions. So I have to count some count of tokens before I blow out and say, go back and reparse it as a function versus a type, or whatever, an arg function versus a no arg function. So again, this would be, as soon as I hit the arrow, I'll go to the next token. So start with a colon, you're a type function, you're a type parameter. And rethink you. And in some of these cases, I just keep the parsing expression, I just hand it off to, and finish out as a type parser, or finish
so
out
in this
function parser.
In this case, the parser has use the colon to disambiguate that this is a type expression.
Yeah.
Okay.
The parser would disambiguate immediately, which would mean that you couldn't have complicated math expressions in there that were just an arbitrary computation followed by, and I'm returning a type. That's not allowed.
Yeah.
Right.
Well, in theory, you could allow that later, but all that computation just has to happen at compile time, or you have compile time.
Yeah, it would have to fold up as a compile time expression, which
if you can't constantly propagate through it, then you lose.
Yeah. Right.
Yeah, that
Did
that's
not
how we have
become a constant expression at compile time, parse time. So therefore, I blow you out. Yeah, maybe.
Which is my assumption that all of your types are also
Right.
must be constants by the time compiling is done.
And my current theory was something like list of A is defined to be a type of, you know, a struct returning me a next, which is a list of a question mark and a value A. And I don't claim that that's any better or any worse. That was what I was thinking I was going to do, except I was asking the question of, you know, square brackets versus just a blank versus round brackets versus Java's angle brackets. That's like ugly. Okay, so you know, which of those do you want? I don't know. And there's list of string, which Visual Basic. Wow, that's interesting. The keyword of to make it more readable. And Julia has curlies. Yeah. And of without any curlies as for, yeah. So those are not, that's not half bad. I have this link to this web page called One Big Grammar web page or something, whatever. It has all the different common language features and how they're implemented in like 30 languages. But it's like 10 years dated now. So it hasn't done any of the more modern language. Doesn't have anything with Scala, doesn't have anything to do with Elm. But it's an interesting purview of how people do all kinds of typing. In fact, I'll throw that in the docs here.
Yeah. On the same note, there is a website that shows type weirdness. It's called counterexamples.com. I would throw that too. It's about types, which is pretty cool. I encourage everyone to counterexamples.com.
Yeah, I can recommend it. It's really well done and well explained.
What, throw a link in? No.
I'll
In AA, can you define a function in that syntax?
In which syntax? In the
If I say function name, open parenthesis, some argument list, close parenthesis equals, and then I give you the function body,
no,
but I don't put the argument list in the function body.
No, it's not my syntax. We could argue it should be, but I don't like that one. Yeah, we could go there.
It just feels a little inconsistent to me that, like, sure, you could have done function definition to look like that in AA.
No, that, yeah, function. I don't do function definitions that way.
But
so
you chose that.
Why would
and my curiosity is, why is types different than functions?
Right, because I don't yet have a syntax for generic types, so I don't have to solve this problem yet.
I added
have
the link
syntax for functions. I have a syntax for types that are not generic. These two don't cross. As soon as I have generic types, which I obviously want, I'm doing them right now, I need to have a syntax for it. Okay.
Yeah, I would argue make it the same as functions because that makes the language a little bit easier to learn because there's one fewer concept of how do variables get bound.
You do have the issue that you can't tell you're looking at a type expression until you get far enough in that you get past the function header. Right, the disambiguation point for the human eye is you find the colon in the middle of the function.
That's true. I can't say at the top that the type of this thing is. Right. Where do you usually put return types if someone is choosing to label the return type in a function?
You either put it on the final expression or you put it after the function as a whole. You can type the function as a whole, or you can put it on the variable. So you put it in a bunch of different places. Yeah, you could put it there as a function as a whole. So you have a function expressions. All functions are anonymous. They're all expressions. So you have a function expression. Now I can put a type there. It has to match the function type, which it would include the return. So there are basically three places you could put it. You can put it on the variable and before the equals sign. I say list equals, and now I have a function, not a type, or foo equals a function, right? Okay, I have a foo colon function expression. I can say equals, each argument can be typed. The return is typed at the last expression or after the expression. Since it's an expression, after any expression, I can put a type expression. I might have to stop talking until this cold clears out.
Yeah. So So that's not any more obvious. I was thinking if someone wants to make it really obvious that something's a type, you just annotate it as a type, except that return value annotation is kind of
like a
far
type
away.
of descriptions does the job. And it's almost ubiquitous in all languages. It's colon type.
Yeah, I'm doing colon type, and you can put it after any expression. And function, all functions are expressions. All anonymous functions are expressions. So you put one there, put it on the variable, put one on each of the parts inside the function. Where do you want it?
I'm a big fan of allowing type descriptions everywhere. It's like, for instance, even in normal method calls, if I like want to ascribe a type to a parameter, then I think the compiler should absolutely let me do it, even if it's not necessary.
Right. Well, they're great annotations. They're great comments on what you intend. So, because they're type checked. The type check comment. It is a fucking type check. That's what it is.
The types are type checked comments.
Yeah, exactly.
Yeah.
All right, I am going to call it because I'm losing my voice. I'm going to cough my head off till I suck on a throat lozenge and whatever. And we're 2 hours in, so it's been a good, fun go round.
Cool, guys. Cool.
Way to make up for missing a week by doing 2 whole hours the next one.
Yeah. I even have the Theodore's been doing the helpful timing marks, so it goes much quicker to go from.
Yeah. The cool things, we gradually increase the duration of the talks because the discussions are getting more organized and more diverse, which is cool. We are getting new members.
Yeah, it was actually a pretty big meeting today too.
More
than usual. All right, folks. Next week.
Okay, guys. Cool.
Fun.
Next week. Fun. Bye.
Bye.